Yeah. I'm Jeffrey Schnapp. My day job is as a cultural historian, and I run a lab at Harvard called the Meta Lab, which is, we call ourselves an idea foundry, a knowledge design laboratory, and a production studio. That somewhat sibylline self-description stands for is really an interest in creating an experimental platform between the arts and humanities and the technology field. And we're particularly devoted to trying to reimagine and reinvent museums, archives, and libraries for the 21st century, really rethinking what brick and mortar institutions are, could be, should be, particularly as the true facade of those institutions becomes their presence on the World Wide Web and in other information-rich settings. So designing experiences, building physical things, museum interactives, experimenting with techniques for telling stories, often at macro scales that are not typical of cultural institutions, new models of teaching, and experience design. Those are all sort of within the fold of what the Meta Lab does. Starting about 5 years ago, I co-founded a robotics company with my friend Greg Lynn, the architect, who teaches at the Angewandte in Vienna, as a matter of fact. That company, which is called Piaggio Fast Forward, is in the business of building new kinds of vehicles that leverage many of the same technologies that self-driving cars do, but in the service of a vision of the future of cities that I would somewhat provocatively describe as the anti-self-driving car vision of the future of cities. We believe profoundly that urban planning is moving away from the automobile-centered model that defined the 20th century, and that the real challenge for the present and future is not reinventing the automobile, but rather inventing new kinds of vehicles that support a vision of the city that's centered on forms of local motion rather than the kind of automobile scale model of movement that characterized the second half of the 20th century. And so our focus in the case of our first product, which we launched on the US market, and currently it's only on the US market at the end of last year, which is the myGito robot, is building robots that reinforce, that serve as a support system for pedestrian mobility choices. So myGito is a follow me robot. It has, as I said, many of the sensing capabilities, the computational capabilities of a self-driving car, but all of those capabilities are used to support pedestrianism. And for those of you who have worked in the area of self-driving vehicles, I think you'll understand right away, one of the main bets that we're placing is that in high density, complex, human-rich environments where people they're the owners of those places, like sidewalks, like plazas, like city squares, like shopping malls, like the hallways of buildings, like lobbies. Self-driving vehicles that aspire to level 5 autonomy are not welcome in those spaces, and they are very unlikely to ever technically resolve the challenges of navigating those spaces. The only way we can build a city where level 5 autonomous automobiles have the same presence that automobiles do in high density cities today is to get rid of the people. And I'm putting it crudely, but this is the truth that I feel that the engineering community rarely addresses, that these choices have design implications for the spaces where automobiles and other kinds of vehicles are present. So while I'm a big fan of autonomous mobility in all its flavors, I think that we have to approach it strategically and tactically with an understanding of what the design implications are for the environments within which these vehicles move. And the vision of the future of cities that I'm committed to, and that the vehicles that we develop at Piaggio Fast Forward are committed to, is a vision that's human-centered, that's focused on recovering streets, from cars, taking them back, reducing the footprint of motorized vehicles in order to expand the footprint for humans, for social activities, for social action within high-density cities. And in a sense, restarting the conversation around mobility with a focus on, in a sense, building a pyramid where as we move out into long distance, controlled environments, autonomy, even level 5 autonomy takes over. Like I think trucks, for example, long distance trucking is a great application. You know, superhighways are a very controlled environment, a relatively easy, quote unquote, environment to develop these kinds of solutions for. But when we get close to those kind of core social spaces that are high population density spaces, spaces where people interact, move around, I think we need to adopt the opposite strategy. And Piaggio Fast Forward is committed to that vision. The myGito robot is a cargo vehicle that follows a pedestrian. It has behaviors that we call smart behaviors that are small bite-sized chunks of autonomy. They are autonomous behaviors, but they're subtle. Often the operator doesn't even realize that the vehicle is adapting to some environmental factor that was triggered by the arrival of somebody coming the other direction, or the presence of a trash can sitting in the middle of the sidewalk, or a hole that needs to be avoided, or an obstacle of some kind. Sometimes those obstacles are navigational, but the whole focus of our design effort is to create the most intuitive human-machine interaction conceivable, where you're not looking at a screen, you're not joysticking, you don't need to read a manual. You can be 5 years old or 85 years old and operate a robot by doing something that you have done since you were a toddler, which is to walk. Your body is the interface. There's no screen mediation between you and the robot. The robot knows how to track you. It uses optical navigation. It doesn't need GPS. It doesn't use Bluetooth. It uses optical tracking, and then it scans the environment in which it operates, and the autonomous behaviors are triggered by recognizing features of that landscape that represent a menace or a problem, a navigational challenge. But all of those sort of algorithmic solutions, which are environmentally and contextually triggered or triggered by the operator behavior, all of those solutions are designed to achieve two goals. One is this highly intuitive and fluid interaction, which requires no particular attention or very limited attention on the part of the human operator. And the second is to observe and respect the etiquette of sidewalk behavior, which sounds simple, but it's extremely complex because we as humans are not particularly self-aware of how complex these behaviors are. The fact that we're constantly changing our interactions between each other, the way we change our spatial distribution as we move around an obstacle, around another person, move with people, without people. So it's all those nuances of behavior that are the focus of our design effort on the software front. The hardware is a self-balancing vehicle that weighs approximately, what does it weigh? About 35 kilos, that carries about 22, 23 kilos of goods, and that can be parked, can be locked in a public place. It's secure, and that allows you to walk more, better, further, with removing one of the impediments that keeps people from choosing to walk rather than to reach for the keys of the car, which is the fact that as we as citizens move around the towns and cities that we live in or we work in or we play in, we carry stuff with us. Humans like to move around the world with stuff, and that stuff is a very powerful driver of mobility choices that are bad for the environment and bad for the community and bad for the societies that we live in. So our ambition is to create an infrastructure that starts at the bottom of the pyramid, which is that most fundamental, most elementary expression of human mobility that is walking, not as the total solution, but as one solution on top of which we have bicycles, we have skateboards, we have, electric scooters, we have public transit, we have automobiles. Why not? But not automobiles as the protagonist, as the driving force behind the cities of today and tomorrow, but automobiles as only one actor and not the dominant actor alongside a kind of reimagined and rebuilt model of future mobility. So that's at core what Piaggio Fast Forward does. We are interested in, we're manufacturing these vehicles in Boston near our headquarters for the consumer market, which is really a challenging market to take on. It's a new product, it's a new product category. Most people don't know they need a robot in their lives to carry their stuff for them. We're also looking at the business-to-business market to a limited degree. There's a lot of interest in the B2B market in these kinds of vehicles, especially as some of the kind of norms are kicking in, in Europe and throughout the world, restricting access of motor vehicles to city centers. It's a very challenging environment. Our robots sell for $3,250, which to some people, many consumers, sounds like a lot of money. But when you talk to anybody in the business world who's ever dealt with robots, they think we left a zero off. It seems incredible that you could have such an intelligent vehicle for such a low cost. So I think that captures for you some of the challenges of trying to develop these new kinds of vehicles that solve mobility problems, but in a way that doesn't slot into existing categories or existing understandings, and that also ask for people to change their habits, to change habits that have excuse me, have solidified over the course of decades and decades of social habit, of social practice. So that's basically a thumbnail sketch of what we're doing. It's a really exciting domain, but it also is a challenging domain, particularly because one of the decisions we made early on in the history of the company was not to try to solve every mobility problem, but rather to really focus on what we see as a kind of core foundational mobility problem. And by that, I mean to allude to the fact that when it comes to legacy historical cities, there are so many obstacles that are built into, hardwired into the landscape. Stairways, steps, the lack of compliance with disabled access and general, access standards. Those challenges are really tough challenges. If you're going to build a robot that walks up steps, it's going to be a monster you don't want to have in your living room or walking around with you in the world. So our decision was to build a vehicle for the way cities and towns are being built today and tomorrow, not to try to solve all of the problems of historical and legacy building practices. So our robots can go up and down elevators, they can go up and down ramps, any environment that has been built or brought up to compliance with European or US access standards over the course of the last 20 years, our robots can navigate with no difficulty at all. They can cover that entire world. When it comes to steps and stairs and other hard obstacles, we don't have a solution for that. And honestly, I don't think that there are interesting robotic solutions for those problems. So that's the position that we've taken, and it's still early days, but I'd be happy to engage in conversation about some of these themes that I just touched upon.
So interesting. I hope that my voice going to be stay bearing with me. The whole conversations, we have a lot of conversation about autonomous driving, autonomous cars, the new forms of mobility. It reminds me a lot to the conversation that we had about unbundled phone lines about 20 years ago, when the cell phone operators basically owned everything and new private companies came up. And the password of the time was the last mile, like from the grid, the infrastructure they had, to the living room, to the human. And I feel like, and it took maybe, I don't know, 10 years or so to get control over the last mile. I feel like with all these conversations about autonomous driving, right now the human is the last mile. Like these little manipulating efforts the humans are doing to feed the bot and then let the bot do the job until it's about to have the human do again these little manual operations between robotic interaction. I'm curious how long this is going to take that we're going to have full interaction with robots.
Mm-hmm. Yeah, I mean, I think, it's interesting that the last mile language is exactly the language that has been carried over to delivery, to the delivery economy. So in a sense, we're exactly in that same place, as you pointed out. But I think for me, the really interesting, and maybe this comes from the fact that I'm a cultural historian by training. I'm not an engineer, although I've always been interested in mechanical engineering. I raced motorcycles for a period of time. I feel very close to the mechanical world, but I come to it with the attitude of a cultural historian and a designer, not an engineer. But I think what interests me in the robotics field is really the increasing intimacy between the world of robotics and everyday life. And so I'm particularly interested in those places where instead of running everything through a screen interface, everything through a smart device, these kinds of new, whether they're vehicles or new, forms of smart devices or machines or Internet of Things devices become woven into the everyday in ways that complement, extend, and create the context for new practices. And that's the sort of design ethos that's behind Piaggio Fast Forward. Our model comes in many ways from our parent company, the Piaggio Group, whose iconic vehicle is the Vespa scooter. If you think of what scooters did in the 1950s, yeah, I also own a vintage one, Nikki, a 1965 one. The scooter was not just a vehicle that solved a logistical problem. It was a lifestyle vehicle that changed the way people thought about mobility, the scale on which they moved around, but also what they did when they got somewhere. And I think, the Vespa was a like a sofa on the main square. It was, a family vehicle. It was a vehicle that, because it had a cut through in the middle, you could wear a skirt on or be dressed, in a priest's outfit. It changed the demographics. Like that's, I think, a very high bar for a design project, but I think it begins to communicate how even in the most high tech pieces of the innovation economy, what really is catalytic are those kinds of gestures. And I think the more you can simplify, the more likely you are to weave those artifacts into the fabric of everyday life. And that's the focus of our effort. We're a completely design-driven company. Greg is an architect, I'm a cultural historian. We didn't even hire an engineer for the first 6 months of the company. We spent all of our time looking at vehicle hacking and customization subcultures. We spent a lot of time looking at the shape of cities and architecture, the built environment. And we spent a lot of time looking opportunistically at areas of technology we thought were interesting precisely because they didn't require a screen interface, that they could be brought into a very intuitive relationship to forms of human endeavor and practice. So again, for us, the idea of turning the human body into the interface and getting away from those little devilish devices we all carry around in our phone is the strong move that interests us. And it goes a little bit in the opposite direction of a lot of trends within other parts of the technology community, but I think it reflects a design-centered ethos.